Hi everyone, this is Ricky Spencer and welcome to the Sociology of Media Voices Seminar Series 2021. This is our second seminar presentation for this year, and we're very privileged to have an IT expert to talk to us about a real interesting and important area for many of us as who are researchers, educators, research students, community members who want to kind of understand in a deeper way what cloud storage is and the ethics behind storage and uh, long-term usage of that material being stored in a virtual space. So I'd just like to first start by doing a welcome of country. We acknowledge the traditional owners of the land, the Wurundjeri, the Warren and Burunongs people of the Kulin Nation, and pay respect to their elders past, present and emerging. So I'm just going to give you a little bit of a brief outline of what we're discussing today to put everything into context. So the storage of data on cloud is a service where data is remotely maintained, managed and backed up. The service is available to users over a network, which is usually the internet. Instead of storing the data on your computer's hard drive or other local storage devices, it allows the user to store data online so that the user can access them from any location via the internet. The cloud provider company makes them available to the user online by keeping the uploaded files on an external server. The internet provides the connection between your computer and the database. Cloud storage reduces hardware and software demands on the user side. This gives universities and other companies using cloud storage services ease and convenience, but can be potentially be costly. Users should also be aware that backing up their data is still required when using cloud storage services, because recovering data from the cloud storage is much slower than your local backup, whereby you save it to a remote database. Accessing and storing data on cloud storage has had several challenges and security risks, thereby making the cloud information inconsistent and unreliable. Thus, the need for improvement and another approach dimensions into computing arises. So that's sort of like the scope, just to put everything into context for people who may not be aware about some of the issues related to cloud technology and information management of data. Today we have Alex Breskin. He is a consultant developer currently working with Thoughtworks. He has worked in the field of information technology for the past 8 years and has consulted for a variety of companies from a range of industries such as warehousing, logistics, marketing research, construction, and finance. Through his experiences, Alex has been involved in projects that utilize distributed systems and processes through cloud technology to collect crucial data and metrics that are key to enriching business decisions and are of particular interest to him in the data and data governance space, as our collective understanding of the risks and opportunities in the field continues to evolve. In his activities outside of works, Alex is a prolific campaigner involved in organising groups by lifting their capacity through good governance, and has advocated on issues particularly within city planning, transport, housing and social justice sphere within the community. In 2019, he was the proud recipient of the PTUA's, which is the Paul Mees Award, along with the Residents Against Mordialloc Freeway Committee as the group secretary, and has run for government on 3 separate occasions. Welcome, Alex, to this series, and thank you for being here to enlighten us. It's over to you.
Thank you very much, and I do pay respects to the Bunurong country of the land in which I meet from here in Mentone. So yeah, I guess I should talk a little bit about what cloud storage is. As you've mentioned, there are private cloud storage providers, and one of the key things to realize is that, well, we can talk about the big conglomerates such as you have your Microsofts in the field, you have Google, you have Amazon with AWS, those aren't the only definitions of cloud. Cloud is, in a sense, a rack of servers that will have a bunch of data storage devices. And in that, you can have yourself a private cloud. So a private cloud is, in essence, just a data center that an organization or even a private individual might have that could have all this information already there. But you still need to connect on it. And one way to do that is through an internet connection, but another way is through a virtual network connection, such as via an Ethernet cable that's completely disconnected from the internet. So there are a few ways through the entire process, but it is in essence just a new question. How do we actually store all our information without necessarily just having it in one point of failure? In the private providers, a lot of them do deal with trying to replicate a lot of this data. So you may have one storage device here, but in all, pretty much as many instances as they can, they replicate that to a second instance. And that's actually a really big part of what a private cloud provider does, is they try to ensure resilience to your data. And where you can actually back this up onto your actual computer. And in essence, if you're using applications such as Google Drive, OneDrive, or any similar provider, you would have that already backed up on your computer, or you could otherwise on demand bring that back, and you might have a list or a manifest of what files you might have. So I guess that's one place where we can start. But I'm happy to answer any questions that you might have, Ricky, in terms of what you would like to know more about the cloud or some of the issues that come out of it.
Okay, so anyone else would like to also add? And I guess I could start by saying, as a research student and academic working in the space of collecting data for my research, I guess for the basics for someone like me, how can I be sure that what I put into the cloud stays in the cloud and I can access it? Because my concern sometimes is, if I'm saving, like when I'm saving my data, normally I will save it to the university server and back up with my own little hard drive. But I'm always fearing that one is more up to date than the other. But also, is it possible, like what could happen if I, say, forgot my passwords and I had a brain freeze? Or could somebody, go into that cloud and pretend they're me or access it and then corrupt that data, especially if I'm doing something of a sensitive nature?
Yeah, so that's a very good question with regards to security. So there's a question, from what I understand, two questions there. There's a question of security and whether you're able to actually ensure that the data is not going to be captured by a third party. There's a question as to the in-between the cloud server as well as yourself, and whether a man in the middle can actually intercept that data. And then there's also the question of what happens when you might not necessarily remember your password, or you might not be able to access that data otherwise. So there's a couple of ways around all of them. I think I'll first stay with the security question, and then I'll move over to ways of trying to ensure that data is still retainable. So with regards to security, this is one of the biggest concerns that the world has had with regards to trying to ensure that all the data that we have is actually secure from external threats. In fact, it's one of the most growing industries is data security. So security has come quite a long way from the 90s. We've tried to ensure that all our systems have some level of encryption, and we found that some levels of encryption have worked better than others. And we've even, for example, with SHA 256 and all that, we've actually deprecated some of these methods in favor of other more robust methods. And it's still an evolving space. With quantum computing, it might be even easier to crack some of these cryptographies for others. But in essence, a lot of that isn't an issue that we as users have to worry too much about. That interception of data is generally dealt with on a far further end of the transport layer that we ourselves as users don't necessarily need to worry about. However, it does mean that we do have some security threats that we do actually need to ensure that we are aware of, such as how secure are our passwords,
Mm.
whether we have access to our computer, whether we have identifiable information on ourselves. So that's one of the key issues that security providers, cloud providers as well, have to be acutely aware of. There's also the question of what happens with the data once it's actually at the cloud side. So on the cloud side, I can't talk about every single private provider, but for the most part, they will do essentially the same thing. What they have is a data center that is pretty much incredibly robust in terms of how they've been built. They try to ensure that they have 3 levels of separation within those buildings. They make sure that all the services that deal with cooling, with firewalls, with the actual data itself are separated out so that the buildings themselves, you can't get from one part of that building to another without getting through a specific amount of security. In fact, one of the things that I know with the Microsoft Azure servers is that they actually do allow people to come inside to do a tour, simply to try to reinforce security methods that they can actually improve on as people do that tour. And it actually makes them think, okay, well, if an employee goes in there, do they have the right level of access? Have they observed, in all senses of the word, the access of least privilege is required for an individual that's just a guest, or for a specific employee, whether their role requires that level of access, essentially trying to ensure that if a bad guy does come inside that building, they can't just exfiltrate information. Then there's also the question of how randomized your information is on those servers. I can't just go into a server and just say, all right, I need to steal this person's data, go into the server, find that exact rack, take out the hard drive, and exfiltrate that. It's all randomized within their servers. It might be in a completely different data center. It might be even 500 kilometers away. So if, say, there was an earthquake that just so happened to destroy the entire building, that won't actually affect your data. It will cause some downtime. And this is one of the big things that a lot of the data providers do give, at least the big 3, is the concept of the service level agreement that requires, they call it like 3 nines of availability, which is 99.9% of the time in the year, you will have access to your information. That 0.1% of the time, which is usually measured in minutes or even hours, is basically time that it may fall over. And that's when you won't be able to actually access that information as quickly as you can. So there is a level of guarantee that the big providers are actually providing when it comes to that level of access. What that means is with that small low windows that they do have, they need to make sure that there is some resilience within their system and that there is a level of regression within their systems. So your data will be both replicated in one data center and another data center somewhere within that same region. But we have another issue there. We need to make sure that everything is still observing local legislation, because legislations here in Australia is going to be different from something that's happening in Germany or within America. Cloud servers will always deal with the idea of ensuring that they have regional integrity. So a server within Australia will always observe Australian laws, but your data will not be replicated, say, to North America or to any other location, unless you specifically require that data to actually go there and you set up all the data centers in that area to work. So another question is with regards to yourself and who you are. So with all the data, with all the concepts of security now evolving, I'm sure everyone has now had to deal with the ever-evolving space of security in terms of trying to get out your phone and putting in your access codes, keeping an authenticator device and everything like that. So there's been an evolution as to how we deal with security. Once it was just what we know. Your password is what we know. But as we found, everyone keeps on clicking, I forgot my password, because that space has evolved so much. We've all had to remember about 1,000 different passwords. It's no longer a useful metric in terms of understanding whether that person actually knows, whether they can actually access that information or not, because it's no longer reliable. So the other thing we need to add into that to enrich that experience of security is to also add in whether you have something that you have. So your phone in that case, if you just need to press a button on your phone, it means that you have your phone, which means we have higher probability of ensuring that you are in fact that person that you talk about, that you claim to be. And then there is another one, which is who you are. So biometrics is a metric there. So if I say, again, I have a phone and it actually asks me, well, what's your fingerprint? And I hold on to my phone and determines that that fingerprint is in fact myself, then I have even more confidence that the person that I'm claiming to be is actually who I am. That means that we don't necessarily need to rely on a single metric to ensure that that person is who they are. And that does increase our probability that we are in fact dealing with the same person. So a lot of cloud providers are now ensuring that people that do forget their passwords are still able to actually get their level of information, because we do have that redundancy where we require it.
Thank you for that. Food for thought. Now it's over to David.
Thanks, Alex. I think you've taught me in a few minutes way more than I knew already about the cloud. The bit I'm interested in, like to raise, is the environmental side of the cloud, which I know is a big issue. A colleague friend of mine, Toby Miller's, with Rick Maxwell's written a few versions of the book Greening the Media, and has written a lot about greenwashing as well in his field. And I don't know if people know, but our TASA colleague Monash Brett Hutchins has been doing work on greening the sports media, and he the first grant application which he made with the ARC, which I gave some advice on, was actually knocked back by the minister. Remember that round a few years ago in the ARC discoveries, where Simon Birmingham, the then minister, knocked back grants that were recommended by expert peer reviewers. One was Brett's, greening the sports media, and anyway, fortunately, he, with not many changes, put it through again the following year, and it was successful. But I have no idea why the Liberal national government would find something offensive in the idea of environmentalism as it is attached to this whole area of media and communication. So could I ask you to comment there on what I understand is a massive load, specifically of energy, but I'm not sure about materials, but certainly energy, that cloud computing demands and its impact on the environment.
Sure. So there is actually so this is a really interesting topic. It's with regards to how much capital is actually required to establish a data center. And I think that there's two things to look at here. So there's first off the question of what happened in the past with regards to computing and where it is currently going to. And I think one of the key things to realize is we've basically gone as a society more from a capital expenditure of getting all this equipment, getting all this stuff. So getting server racks, getting computers, and getting all the CPUs. What you essentially saw is a very decentralized model of how we've actually dealt with computing power, which meant that it was actually harder to actually return metrics as to whether we actually have an ecologically impactful computing system, or rather whether it was something that was just occurring on a house-by-house basis. So this is one of the I'm not going to say it's one of the good things about cloud computing, because there are places where cloud computing may in fact increase the amount of power load, But that's the thing. We're in very new territory here with regards to cloud computing and where it's going and the uptake of cloud computing as we go, where we're now able to actually determine, well, what is the actual impacts environmentally. But also with the pandemic, one of the key things that we've seen in just the last year is just a huge uptake of IT, which meant that there's been even more scaling up of the operational expense of cloud computing. And I think I should probably step back there, and it's a key concept to realize. A lot of companies are now moving away from the capital expenditure of having computers and having stuff that will eventually depreciate to offloading that to a private provider like Azure, to AWS, to GCP, which is the three big companies in the sphere. What that means is that we know that the companies themselves, the private companies that actually have these cloud computers, these private clouds, are trying to offload a lot of that burden. This does have an economy of scale proposition, which means that you may find that you might see energy use increase or decrease. But what it does mean is that with regards to trying to share data, power load and all that, you do have more opportunities to see specific power generation happen from those locations. But also they need to have their own generators and all that. So in case there is a brownout or blackout, they're able to stay resilient, because that's one of the key things that they also try to ensure and provide to their customer base, is that their business will continue regardless of a disaster, such as a blackout, such as an earthquake or whatever you have. I can't quite answer with regards to whether whether cloud computing has increased or decreased the amount of overall power energy consumption is required, because I don't necessarily know that information myself. However, it would now be easier with cloud computing to actually get that sort of metric, because you will now have a facility dedicated to that type of consumption, in essence. I think that's one point, but I think another point that I should make is something that I've noticed around my area. So, and when I say area, I mean where I live. So we have a portion of Kingston, which is the local government area in Melbourne, where we have Green Wedge, and the Green Wedge by the government is being reconsidered in terms of what its utility is. And one thing that they're saying that Green Wedge should be used for, instead of just rural utility only, they're now saying, well, data centers could also be something that could be added into the Green Wedge. So a data center is, in essence, a massive warehouse. It's a robust warehouse. It has all the separations I talked about earlier, but that has certain problems with it, because it's just all this intensive capital use in terms of real estate that drives away from what its original use was. So you will see, with regards to the uptake of cloud, more data centers that then have to be spooled up to try to deal with demand. And that does have a serious ecological effect, because then we're losing a lot of green spaces. Now that is a serious threat. I think that's about as far as I can answer that question. But if there's any further information, like the decision by Simon Birmingham, I'd definitely be interested in hearing that.
Okay, thanks for that. Just if I just respond very quickly. Yeah, I'm actually quite close to a massive data center on the way out to Sydney Airport, one of the largest, I think, in Australia. Just a quick anecdote from the last physical TASA that I went to, which goes to precisely what you said. I came out of a seminar session, and Rebecca Olive, some of you might know, TASA member, she'd forgotten her laptop, and I kind of looked around, I found it, and I gave it to her, and she laughed about me retrieving her laptop, and she said, "Oh, it doesn't really matter; it's all in the cloud anyway." It was which is precisely the point that you're talking about, the disconnection of the hardware from the information, which is somehow dematerialized. So thank you for that.
Thank you, David, for that really interesting point. And as I think I was mentioning before we started, I was saying to Alex, is that in my generation, in my early 50s, is I grew up that notion that everything was hard, you know, that we had that floppy disk in the 80s. And I remember fearing it because that was the fear that was put into us at university then, to say, make sure you've got it on your floppy and protect your floppy. If it gets connected to something, you would lose it. So we grew up with this fear. And then once we got into the from remote physical to internal, we thought, oh, okay, internal. Oh, you know, it took me a while to get used to being able to, because I was still used to the floppy and the disk as more a safer option. So it took me a while to get used to that. And then virtual came. And I'm still like, because I still fear. So I think, oh, but I can't hold it. How can I trust? That element of trusting one's own data, one research into the hands, sort of the virtual cosmos, it creates that sense of anxiety. But as you alluded to, David, your colleague, you know, we're now used to the idea, okay, if I lose it, it's out there in Netherlands, and that's wonderful. And that really does heighten this notion that we still have, when something you cannot see, but we're relying on its integrity and the storage, it does sort of conjugate in my mind, how is this evolving and where will it go to? And I just want to now lead to John, who has a question. Yep, there you go.
Okay, yeah, sorry, thanks for that. Yeah, so I'm kind of asking, back to the security idea, and I was thinking when you're talking about that, what about biodata and that, you know, I guess I'm asking from a surveillance capitalist type of capitalism sort of perspective, you know, and biodata, fingerprints, like I've been, I haven't used a fingerprint on my phone or laptop, you know, for a while because, you know, just venturing into this area with what the big companies, the big tech companies do, it's all about data. Where does the cloud sit with that? You know, I've got Apple Cloud and that sort of thing. So is there a way that this data like fingerprints, iris, face scans, people are so just look into their phone and I can't help seeing that as data, and the possibility of that linking up with, like, you know, people can get what is it, the family tree sort of thing that you can do, that, you know, the company that does that sort of thing, and this massive picture of you, it's just, we don't know what they do, and to a certain extent the companies are keeping all data, and because they might come in handy sometime. And if you see some of the work they've, you know, that they've done on what's coming next kind of thing, like predictive shopping for Amazon, and you know, well, what happened with the Microsoft and that. Anyway, so I should get to my point. If you've got something could say about the cloud and that type of thing, and link that sort of data linking up.
Absolutely, and I think that this is a very key question that we do need to ask ourselves in terms of data governance, because what we actually have, what you're actually talking about is a question of the separation of personal identifiable information. And that type of data is an incredibly powerful tool to big companies, to researchers, to all sorts of people. And it's also useful for people that want to abuse it. How many times have we all received a random phone call from, you know, someone that seems to just have your phone number and your name saying, oh, you know, this is something that's happening. Would you like to invest in a share or something along those lines? Well, I didn't give them that information. Why are they asking me? We saw some massive data breaches in just the last 10 years. And in fact, the last decade has seen such huge amounts of privacy, in essence, just complete privacy breaches, that we all should be really scared, and rightfully so, about how this data is actually being used. So with cloud providers, I guess going back to the layer where we're talking about security, and these are all layers, and I'll define that layer of security as software as a service. It is a piece of information. It's a piece of the platform that basically gateways you from you as a user accessing your data. However, that all lives in the cloud as well. What information it receives, how is it going to use that? How now does your identity belong in the cloud, and how it involves all the different systems to determine your role, your authentication, your authorization. So different regions do it differently. In Germany, for example, or in the European Union, we might know about GDPR. So that's an incredibly important piece of legislation that basically defines that if you ever put in information into a database, you need to strip out specific information about an individual if it's not actually useful for your day-to-day operations. And it's actually pretty harsh in terms of what you have to strip out. So basically, you can't keep a person's full name, you can't keep their number, you can't keep their email address, you can't keep anything that may, in essence, link up towards an individual. That also includes metadata, so stuff like biometrics, that sort of thing. Not every country does it that way. So Australia has some of the weakest policies when it comes to that type of information. But for the most part, a lot of companies that want to do trade within the European Union do tend to try to move towards keeping to GDPR compliance. So cloud providers are very aware of that, and that's where governments are actually an important space to ensure that big companies do have a reason to actually get that level of information as far away from the private company's hands as possible. But you also see some big companies truly trying their best to try to ensure that private information like that isn't kept. One of the key things that we have to realize is, with the question of security, it's not a question of if your data is going to be exfiltrated. Your information will be exfiltrated. It's a question of when. And that's an important thing to realize. So when we do have that information, we need to ensure that if it's meant for a very specific purpose, like, for example, I need to log into my phone. All right, cool. I put in my fingerprints. I then go through and connect on, and I've got all my information right there. One of the things that I'm hoping that phone will do is have some sort of segregation between my fingerprint and who I am in the databases, and ensure that there is some way of ensuring that the encryption is there to keep it away from anyone's hands that don't have the right private key. There are security concerns that need to be integrated in this entire process. But we see a lot of these, very simple security concerns under threat by governments as well. So, for example, I know that America, in the USA, they're trying to introduce, or they have introduced legislation that requires a backend for their security services to actually get in onto your device. And that poses a very hard implementation question for how do you conform to GDPR while also conforming to a security legislation that is actually very much counter to that. That's where treaties and figuring out how to interface with these on a global governance scale actually comes into play, and where free trade agreements and all that come into play as well. But it is our job, as myself as a technologist and your job as researchers, to in essence always interrogate this type of thing and ensure that these security threats that do pop up, because personally identifiable information is readily accessible in one jurisdiction, not the other, that's identified, that's properly researched, and then people can actually implement measures or present to government that these things need to be addressed pretty much immediately so that we don't have these issues in the future. I think that's one part of the issue. I think the other part of the issue is with regards to keeping stuff on the cloud and, trying to make sure that you don't have things being exfiltrated. Like I said, there is your SLA, your service level agreement, that essentially your Azures of the world, your GCPs, your AWS is they do have a very specific post-mortem system in place where they talk about where they may have found a breach. One of the bigger breaches that occurred recently was, I think, on an Azure server where a virtualization, so low level, a virtualization server actually got jumped by a virus. And what that meant is, when I talk about, you have your hard drives in, you might have multiple different people's hard drives on a single hard drive, and they're all virtualized. And you have a Docker container that actually deals with all of them as if they're all their own individual thing, even if they don't have the actual physical elements of that thing. When that gets jumped, that means you can access something else that you shouldn't necessarily have. And that is a potential exfiltration point. When that happened, it caused a huge uproar. The first thing that Microsoft did when they found out that that was occurring on their systems was they basically sent out an email to all their customers saying, all right, we've just realized that this is now occurring. We're deploying our resources to ensure that this isn't going to cause any issues. Be aware that this is happening. And in essence, they said that they're going to have to patch this out as soon as it occurred. They put in bounties for those sorts of things, where they actually ask a person to act like a black hat hacker, which is a white hat hacker in essence, a person that is trying to do penetration tests on a server to see what vulnerabilities exist for the bounty and for, well, perhaps for the bounty, but for, in essence, trying to do a good thing for the community. And they get paid good money to find these vulnerabilities, give a very clear explanation as to how they exploited that vulnerability and how they managed to exfiltrate data that they shouldn't have. But that does mean that there is, at that stage, a loss of SLA. But that's in essence where a lot of the IT sector is going. We're building in resilience. In Netflix, for example, they've implemented something called the Chaos Monkey. And in, the Chaos Monkey is this idea that if a monkey were to go into your server room and start removing a hard drive, I want to make sure that I still have Netflix wherever I am. So in essence, the Chaos Monkey is a program that just at random disconnects something. And that's by purpose. It's meant to test continually their resilience. And it's meant to make sure that the people that's implementing their software, their actual developers and their architects, to say, all right, well, we know that this is going to happen because we have this really annoying system that's actually doing this. We need to make sure that we're building in that redundancy. In the same sense, we try to do that with exfiltration of security information.
Wow, that's incredible. That sounds wonderful. It blows my mind. And I guess one question I want to add, or following on this, that comes to my mind is when we're talking about virtual storage, the end life of a particular institution or an organization that you're involved with, for whatever. And we know things in postmodern society, things come and go. What happens to that information? And perhaps we'll give an example, say, of a political party or something that forms, stores all this information virtually. Because it's, and I'll move away, I won't talk about medical because there's all those legislations and stuff in place. But what happens to us, say that, and you're involved in policy, you've got in data, all sorts of information. Who owns it, and what happens to it? Like, doesn't stay in the virtual space, floating on the cosmos?
Well, I think this is a really good question, because at the end of the day, and this is something that we haven't really explored as a society, is what happens when Google, Microsoft, or Amazon actually cease to be. Everything in life is, has an end life, right? And while we may consider that a company may not necessarily have a mortal end as an individual does, eventually they do fail. And we've seen that, across the span of human history. An empire falls, so does a company. And that does bring the question of what happens with Amazon, what happens to Google, what happens to Microsoft. Maybe you'll have that situation where Microsoft really wants that data. They actually buy that information from one of the other providers. Okay, well, that works to a degree. But then, there's also the question of, well, what happens if all three of these go, or what happens if we have an entire provider that just has to go insolvent pretty much right now, right here? Who has control over that information? And we haven't actually figured out what infrastructure means. What is the question of, we haven't answered the question of whether data is actually an essential service, or whether it's an essential infrastructure. With the roads, it's an essential infrastructure. We know that governments deal with that. But in essence, your data is part of your life as well. And that ownership is something that should be determined by the people in its own regard. I would believe that we should be going towards an idea that our data and our data centers and all that, and it's actually a public utility, much like a power plant would be. It's a utility because if we do not have it, we don't have a basic human right. And that's part of what the internet should be all about. And now that the cloud and our online storage of information has gone to that stage, we do very much need to see it in about the same light. Because, well, what happens if Microsoft, just on the basis of another one of its companies, or maybe its parent company, has to change the way it operates that might negatively affect another country? There is a way that one country has dealt with that, and that was actually China. So in China, the actual board of a company has to be 50% Chinese, and then 50% whatever the other shareholder should be. So with Microsoft, they actually had to spool up an entirely new company within China to deal with all their cloud service provisions. They still can operate, in this case, within the wider Microsoft infrastructure for Azure. But there's quite a bit of significant overhead when it comes to operating within China specifically. And that's the same with a lot of the other providers as well.
Great, thank you. And we've got David now who'd like to jump in and ask you a question, Alex.
Thanks. Yeah, reason I wanted to jump in was to kind of follow up on that question. I was thinking of Paul Virilio when we were talking, and his idea that with the invention comes the catastrophe. The idea that as soon as something is imagined and starts to be operationalized, at that same moment, catastrophic failure comes into being, the prospect of it. And so you talked about the many ways in which this system is designed to prevent catastrophic failure. But can you imagine it? Can you imagine, its catastrophic collapse? And if so, how could that happen?
Well, so with regards to the catastrophic collapse, I think like I said, with regards to a company actually failing, that's when you're going to have your most catastrophic collapse. That's when you start to have, entire pieces of data that's just completely unsalvageable. And that might be something that, all these private companies, all these private people that want to actually be able to access it from Azure, whatever, they might not necessarily be able to get to it. And, actually that has occurred for some private providers. That's much smaller on the food chain when it came down to it. But with regards to the bigger providers, I'm fearing that what will occur is that it's going to end up being one of those situations where they're too big to fail. And your issue will be that governments will end up bailing them out more than anything. Sure. And I think that's...
sorry, you might have slightly misunderstood me. I get the idea of a company failing, collapsing. Evergrande in China at the moment, has had that very question, which is, I know Evergrande because it runs the biggest football team in Asia. So I don't know what happens to the team. I was really talking more about technological catastrophe. Can that be imagined? Not just a company collapsing for some reason or going out of business, but some imminent technological cause. Can that be imagined?
Yeah, so one of the things that cloud providers do quite well is actually try to figure out what technological issue may occur within this, their entire ecosystem, which is why they've built it with such an architecture where as soon as, even the point of which you connect from the computer to the cloud itself is being managed. And with that, they also determine what the SLA is, the service level agreement is between that place and the other place. I think that's where it's actually quite difficult to imagine these technological collapses in terms of where in that whole value stream it will actually fall apart. Because in essence, the whole idea of the cloud is to be as robust as possible. It's to be highly modular. It's to be incredibly to have as much regression in it as possible, that I could swap out one server for another server, still have the exact same thing. When it came to the question of natural disasters, because you have these massive conglomerates that decide to build a data center here and a data center there, link them together and say, this is where my data set is between these two areas, that too has jumped that issue of technological collapse in that essence. I think that the question, I think that with regards to trying to conceive this question, I've actually looked through all the different ways it may have collapsed beyond the organization itself collapsing. I think that is actually the highest probability that eventually that will be the place where it will fail. But when it comes to the actual question of, will a data center be unmaintained and therefore eventually degrade and fall apart, I can't necessarily see that happening, because there's already protection levels that's being built into the system and into the architecture of this entire thing that we call the cloud, that it's very difficult to see that happening. Whereas, for example, if you have your private cloud, say on university campus, well, that will, of course, be prone to fires, that would be prone to floods, that would be prone to a whole bunch of different things that could very much destroy your data. That isn't the case on a private cloud provider, which does guarantee that service level agreement. So that's the issue there. And I think that there are perhaps other factors that might cause an issue with this sort of thing. Like, for example, what happens if our internet connections aren't able to actually connect onto the cloud? What happens if our homes are the place where the point of failure occurs? What happens if Telstra isn't able to maintain their lines to actually get to the cloud? What happens if we have that type of consequence? I'm not too sure how to answer that, because it's such a distributed network that it hasn't really been something that I've really examined that far, but I don't necessarily think it's as high of a chance of causing unmitigated failure as, say, an organization collapsing, such as these big ones. Perhaps we could talk about litigative issues as well. Like, what happens if you have legislation that has essentially made it so it's impossible to have cloud servers? What happens then? I don't necessarily think that that's truly going to cause an endgame result. But it will require a time of transition, which may be disruptive in its own way.
Okay, well, that's been such a great insight, and we're kind of coming towards the end of the session now. We've got about 5 minutes left. I had a question that was posed about, can you recommend any readings or in this area that will kind of enlighten us and people listening to this podcast that really want to explore this in further details, so we can be kind of up to date? And if you don't have access to that, Alex, we can definitely get everyone's email and send it to them. But I'm just curious, is there any person that you've read or researched that has really kind of made you sort of think, oh, okay, it's really struck you as something that's quite, yeah.
Well, in terms of where I've actually learned a lot of this stuff, it has been a lot on the ground instead of through research, through papers and all that. So with regards to where I've learned this, the very basics of cloud fundamentals, it was actually through Azure fundamentals, which you may be able to find online. And you can get certified in the very basics of the cloud. It is quite a harsh exam. It's quite a lot of reading, and it's about 1,000 points that you need to get through. to actually get, I believe you need 700 to 1,000 to actually manage to get the certification. There are several levels above that, like Azure Partner, Azure Solution Architect, that sort of thing. I will try to find information and people that you can actually go through. I have gone through quite a few videos. I'm a very visual person. I like to see videos which goes through all the information, all the technical information step by step. And I have read them quite a few times. I'm going to have to come back to you with actual names and faces and YouTube channels. But yeah, definitely.
Yeah. That would be wonderful. And I'd just like to let everybody know too, this has been an interesting area. It's something that I've sort of started to delve into, even in my research, which is so different. But however, the collection of sensitive data that I'm doing is one of my concerns. And the next session we're running, we're going to be exploring more about the life cycle of storage of data and what happens to individuals. You know, we die, we leave things. Can we leave a will to say where our data? Do we have a right ownership of data? Or as some of us who signed off on research grants, you know, and the ownership for a government, who owns that raw data, and can we or does it stay? And the other area, and I love David's the catastrophe, I'd love to explore that more, because I think we're living in a space now with globalization and interconnections. All these things fascinate us, and we need to know, you know, we talk about laws and we talk about sharing data. And if I was to do my research, say in Thailand, you know, and I want to do a cross-cultural reference to something that's happened in North America, you know, who owns that? And is it possible that a country can, or a government can take that away, or for whatever, even if it's stripped, as you were mentioning? But still, those sort of things kind of, I think, are important, especially for new research and all researchers and educationalists, to people who company owners of data. We have so much data that we take from us now. Centrelink holds data. Everything we do now at the touch of a phone, we coordinate. And one of the areas that some students have been asking me about, and I don't have an answer, is COVID-19. We're collecting data where people enter. And one of my colleagues was commenting that there's a kind of like an undercurrent there where police are kind of considering, you know, if they're looking for somebody, can they have access to that data right through to the individual to find out where they're at? And this kind of raises to me many questions around the philosophy of privacy, you know, in cyberspace. And are we losing our sense of self through the surveillance? And it kind of, I don't want to go to my love of Foucault, but I'm kind of thinking, oh, you know, this to me starts to what's not being said. So in our next session, we will definitely would love to explore that further, and I hope everyone can come along, and we'll put times, because it's been wonderful. Thank you so much, Alex, for your time, and thank you all the people who've attended. It's been wonderful. Does anyone want to make any closing comments before we close off? David, did you want to add anything?
So thank you, Ricky, especially for running it, and Alex for really expanding my meager knowledge base on this topic really well.
I hope to see you again, David, for our next session, because I think it's going to be really important to really explore this issue of continuity and foreverness, if I could be so blasé with research. You know, we're used to the old notions of libraries, you know, and Aristotle, you know, we look at Greek, where we held data in a tablet in the form of some sort of symbolic. And I'm wondering, are there anthropologists now considering how does data then get conserved and then captured, that sort of footprint of information? So we have so much to explore. Thank you everyone for joining us today. I'll send out information to everyone. This video will be uploaded onto TASA, so you'll be able to watch it again with links. Please even talk to your colleagues if they'd love to attend. We might even get another with Alex, another upper person, also talking about it from a philosophical lens as well, about privacy and humanity, because to me it does touch on these layers, as Alex was saying, the biometrics, and we're moving into this notion of almost digital human android kind of thinking. You know, it's like from the brain to the other brain. So yeah, as you can see, I get excited by all this. So thank you everyone so much for coming today. It's been an absolute pleasure.